The geometric distribution is another distribution very similar to the binomial distribution from our studies of discrete probability distributions. In a geometric distribution, the goal is to find the probability of the first success occurring before a certain trial, in this case the nth trial. In the example below, we say, suppose we're rolling a die. What is the probability that we will roll our first 4 on the 5th roll? For something to be geometric, it has 4 requirements. They should look very similar. The first requirement is that each observation is either success or failure. The probability of success is the same for each observation. The observations are independent. These 3 should look exactly the same as what we saw in the binomial distribution, so the only difference is what's the variable of interest. In this case, it's the number of trials required to obtain the first success. Going back to that original example, we're rolling a die. We want to know what the probability would be that we would roll 5 times and not get a 4 until that 5th roll. That might look like this. The probability that x equals 5. So once again, we're concerned with that being on the 5th roll. And we can see that 5/6 would be the probability of not getting a 4. And so we have 4 of those, the first 4 rolls being not getting a 4. And then finally we get the 4 on the 5th roll, and that one's 1/6. Together we get 0.0804. Similar to what we did with the binomial distribution, we might rewrite this using exponential notation. And if we take out the numbers and generalize that, the formula for the geometric distribution looks like this. If x has a geometric distribution, then we would still need to know what p is, the probability of success on each trial. 1 minus p means the probability of failure. X is what we're counting and what trial we are on. The probability that success occurs on the nth trial. So once again, that formula looks like this. Remember, n is the trial we want to have success for the first time on, and p is the probability of succeeding. Ben takes a multiple choice test that has 5 choices for each question. Let x equal the number problem on the test. What's the probability that his first correct answer occurs on problem 6? X is 6, that's what we're looking for. The probability he succeeds is just going to come from guessing. There are 5 potential questions. There's only 1 correct one, so 1 out of 5 is the probability of success in this case. And so if we want to find the probability that x equals 6, we're going to take the probability that he fails 5 times, or 0.8 to the 5th, times 0.2, the probability that he would succeed. And that gives us 0.0655. Sometimes we have problems that ask us the probability that it takes more than a certain number of trials, n trials, to achieve success. In this case, we're looking at the probability that x is greater than some number. And you can see that the formula there is 1 minus p to the n. In other words, however many failures we need until we reach that first success. So an example in that case would be that once again Ben is taking this multiple choice test that has 5 choices for each question, and x is the number of problem on the test. What is the probability that it takes more than 10 questions before he gets 1 right? In this case, we're saying what's the probability that x is greater than 10? 0.2 is the probability of success again. So we take 1 minus 0.2 to the 10th, and that's where we get the solution, 0.1074. Just like we did with the binomial distribution and previous discrete distributions, we'd like to be able to talk about center and spread. So the expected value is the same thing as the mean, the average or expected number of trials needed to get the first success. The mean of that is 1 divided by p. Sometimes we want to know about the spread. We can start with the variance. Variance is 1 minus p over p squared. Remember that if we want standard deviation, we just need to take the square root of that value. In our final example, Ben's still taking this multiple choice test that he's guessing on. How many questions must Ben answer on average in order to get his first question correct? All they're asking for is to find the mean. That's going to be 1 over p. 1 divided by 0.2 is 5.